Hi guys, Mr. Starry. Today I want to talk about standard form, and along with point slope form and slope intercept form, this is like the last form that we like to see equations take for graphing purposes and for other purposes that are kind of well beyond this video. Well, what is standard form? This is what standard form looks like. AX plus BY equals C. So essentially we have an X term, a Y term, and then we have just a constant or a number on the other side of the equal sign. So to be in standard form, that's what we're going to try and accomplish, is an X term followed by a Y term equals some sort of number or a constant on the other side. Now the catch is A, B, and C all need to be integers. They need to be positive or negative whole numbers. And most times it works out that way, but what happens if it doesn't? We're going to find out in number 3 here. You'll see that the first two kind of work out the way we want, and then how do we handle when it doesn't? Well, our goal today is, can we convert these equations into standard form? Now, what you'll notice is these guys are probably pretty recognizable. This guy's slope-intercept form, this guy is point-slope form, and this guy is, again, slope-intercept form. But let's take a look. Again, the goal is we want AX plus BY equals C. Now, what can be a little confusing is even though it says plus, sometimes we can see a minus there as well, and that's okay, that's fine. And remember, we're just looking for integers, positive or negative whole numbers. So let's go. What we're trying to do here is, we have an equation to solve. So if I'm trying to match this, what I need to do is I have an X term on the right side. So I need to get that over to the left by using good solving strategies. Well, how do I move things across the equal sign? Well, I can add 2x here. And what that does for me is now I have on the left side, I have 2x plus y equals 4. And what you'll see with this one, with pretty much little to no effort, I've converted this to standard form. Notice I have an X term followed by a Y term equals some sort of number or a constant. Now, just to check, is my A an integer? Yes, it is, right? 2 is an integer. Is my B an integer? Well, I don't see a B, but remember, I can't always draw that 1 in there, so technically there is a 1. So yeah, 1 is an integer, we're good to go. And 4 is an integer, so we're good to go there as well. Done. That is in standard form. Now, what you'll notice about point-slope form is a little bit more work needs to happen. We got to pull some other strategies in. So again, we're still trying to get all my X and Y terms over here, trying to get all my numbers over here and clean this thing up as much as possible. Well, what you'll notice is you have some distribution to do. So let's not forget, 3 times X gives me 3X. 3 times positive 1 gives me positive 3. Let's rewrite. Let's try not to do too much in one step here. Now, I can start kind of moving things around, and really it's kind of up to you, but the goal needs to be my X and Y term on the left, a number on the right. So what I like to do is I see this number kind of floating with my Y. It's a minus 8, so let's go ahead and get rid of that by adding 8. Notice the only thing that I can add 8 to over here is this positive 3 because it doesn't have an X with it. Well, what happens? I'm left with Y equals 3X plus 11. Good. Awesome. Now, notice everything's kind of cleaned up the way I need it to be, but still, I'm not in the order that I need to be. Notice my equal sign is kind of in between my X and Y, and I don't want it there, right? I need an X term, Y term equals a number or a constant. So I need to move this X term. Well, how do I move a positive 3X? Well, I'm going to subtract 3X. And when I do that, I'm left with negative 3X plus Y equals 11. And again, just like number 1, we have an X term, Y term equals a number. Well, my last check is, are they integers? Well, they are, right? Negative 3 is an integer, 1 is an integer, and 11 is an integer. So this right here would be in standard form. Last but not least, well, looks like we have a fraction involved, and that's okay. let's kind of do what we know how to do already. Well, I know I need the x term over here, So I'm going to go ahead and subtract 4/5 x minus 4/5 x. And what that leaves me with is negative 4/5 x plus y equals 2. And you're like, well, Miss Starry, that looks like standard form. It does, right? I have an x, a y equals a number, or a 2 in this case, but it doesn't pass this test. So what do? How do we fix that? How can I make this into something where my coefficients of x, y, and the guy on the other side, the constant, are all, whole numbers or integers? Well, it's actually a pretty easy solution, but it's kind of some weird thinking. So, long story short, we're going to multiply by any denominators that we see. So if we look, okay, I see a denominator of 5, right? And the reason is it's very easy to get rid of a fraction that is fifths by multiplying it by 5. Now what we have to remember to do is we're actually going to multiply everything in this equation by 5. So what's it look like? Well, we're going to take this whole thing, we're going to multiply it by 5. And again, the goal is to make it an integer. That's why we have to do that. Well, let's do it. It's almost like the distributive property, right? So we have to distribute. What's negative 4/5 times 5? Well, that would be negative 4, right? Followed by the x. So negative 4/5 x, when multiplied by 5, turns into negative 4x. But very similar to like reducing a fraction or creating a fraction that isn't reduced but still equivalent, we have to do the same thing everywhere. So I need to do, what is my positive y times 5? Well, that would be positive 5y. And even across the equal sign, equals, what's 5 times 2? That's 10. And what you've just done is, even though this is still kind of standard form, we like to see a, b, and c all be integers. And notice by multiplying by the denominator of the fraction we see, that kind of fixed that for us. All right? That's kind of a quick overview of converting to standard form. But that's all I have for you in this one today, guys. We'll talk to you in the next one.